Hi everyone. Since I couldn't make class today, I decided I would put together 6 short slides here that introduce you to the ideas of a random variable, a probability distribution, and moments, namely expected value and variance. So there's just 6 slides here. This should only take about 8 or 10 minutes. So let's first talk about the idea of a random variable. If you ask a mathematician, they give you a very technical definition of what a random variable is, involving all sorts of equations and technical notions. For us, a random variable is just anything you're not sure about, any uncertain outcome whatsoever. So this could be something as simple as whether a coin flip comes up heads or tails. It could be the winning team in the NCAA basketball tournament. It could be continuous. In other words, could take any range of values, above 0 here. It could be the value of Apple stock next year. Or it could be something that, while not literally infinite, seems practically infinite. Consider the set of all names of people in the world. The name of the next new person you meet. That would be a random variable taking values in that set of all possible names. Now, a probability distribution describes a random variable as a list of 2 things. So first of all, there's the sample space. And this is the technical term for the set of all of the possible outcomes for the random variable. So in the case of the value of Apple stock next year, the sample space would be any positive real number. There's not really any necessary upper bound to the value of Apple stock. In the case of the winning team in the NCAA basketball tournament, here we are coming up to Final Four weekend, so that'll be one of the 4 teams still in it. If you're talking about the name of the next new person you meet, the sample space there, like we mentioned, it's very complicated. There's a lot of possible names, but it's still a finite set. So no matter what the random variable is, it's going to have a sample space, and the possibilities we call events. All right, so the probability distribution lists the events in the sample space, and then it also lists the probability for each of those events. Very simple. So we'll come soon to the idea of some very common probability distributions that you've met, things like the binomial distribution, one that you may not have met called the Poisson, and then one that you've certainly met, the normal distribution. But for now, let's focus on a simple example, which is going to be the outcome of rolling 2 dice. It's a common game in Las Vegas. All right, so let's say you roll 2 dice. The dice have 1, 2, 3, 4, 5, 6 on the 6 sides, and let's let our random variable x be the sum of the 2 dice. So if you just make a table here, the outcome for the first die and the outcome for the second die, you just make a table of what the sums are, you just start counting events. You can notice there's 1 way to get a 2, 2 ways to get a 3, 3 ways to get a 4, and so forth. And all of these possible combinations are equally likely. So our probability distribution for the random variable looks like this. Here are all the possibilities, all the numbers between 2 and 12, and here are the corresponding probabilities. And if you check, these all have to add up to 1. There are 36 possibilities, 6 ways to get a 7, 4 ways to get a 9, and so forth. Okay, so very simple. It's going back to our definition. It's a list of the possible outcomes, the events, together with their probabilities. All right, let's talk about expected value. So you've certainly met this idea before. Here's the technical definition of the expected value. If the random variable has this sample space where it can take on the values little x1 up to little x capital M here, so there's capital M possibilities, that's the size of the sample space. The expected value is given by this sum right here. So we sum over all of the possible events in the sample space. Notice this index of summation is going from k equals 1 up to m, the possibilities in the sample space. And we multiply for each of those elements in the sum, we're multiplying together the event itself times the probability that the random variable has that event. So one way to describe this in words, it's the weighted average of the possible outcomes, here are the possible outcomes, where the weight on each event is that event's probability. So if you work through the dice example, here is the first possibility, rolling a 2, a sum of the 2 dice being all 1 and a 1, so a 2. That has probability 1 out of 36. Rolling a 3 has probability 2 out of 36, and so forth. So you just sum up all those terms, and you end up with 7. That's the expected value. And that's measuring the center of the probability distribution. The variance measures the spread, or the dispersion of the probability distribution. Let's again suppose that the random variable has that same sample space as before, x1 up to xm. Then the variance has this definition. So we could define it in either of these 2 ways right here. So the variance is itself an expected value. It's just not the expected value of x. it's the expected value of the squared deviation of x from its mean. So if you look what's inside these square brackets right here, x minus the expectation of x squared, that's like a residual in a regression model. There's an analogy to be drawn out there, and then we will draw that out later in the course. We square that deviation right there, and then we take the expected value of that squared deviation. And so if we just write that out longhand, you can see that all of the possibilities here are x sub k, the event k, minus the mean squared, weighted by the probability that x takes on the value, little x sub k. So again, saying that in words, it's the weighted average of the squared deviations from the mean, where the weights are the probabilities. And so if we churn through this formula in the dice example, what's the first term in this sum? Well, the first entry was a 2 and the mean was a 7. So this term right here would be 2 minus 7 squared, and the probability would be 1 out of 36. The next term in the sum, k equals 2, corresponded to the outcome 3. So 3 minus 7 squared is the deviation, and the probability is 2 out of 36. You just carry on in this form right here, and you sum up all of those contributions to variance, and you end up with 5.83. Now there's nothing wrong with the variance. The only thing that's confusing about it is all of these squares right here mean that the units of the variance are in the square of whatever the units you're originally measuring the problem in. So it's more common to quote the standard deviation, which is to simply take the square root of the variance right here. So to calculate the standard deviation, first you have to calculate the variance, and then we just take the square root of 5.83. So to sum up, simple ideas. There's the idea of a random variable, anything we're not sure about. There's the idea of a probability distribution, which lists the possible events for the random variable together with the probabilities. And then there's the idea of expected value and variance. And those are examples of a more general idea called moments of a probability distribution, which are more general descriptions of the shape of that distribution. The mean is the center, the variance is the spread. And when we get into talking about correlated random variables, we'll learn about other interesting types of moments as well.